Hello, welcome back to Cracking the Cryptic, and today a puzzle by Molly Boody. It's the first time Molly's written to us, so I'm saying it's a debut on the channel. And it's very hard to pronounce the title of this puzzle because it's just 3 question marks, and there actually look like there are 4 question marks in the grid. We will get to this in a moment. It's very neatly done. I will talk you through the rules shortly. None of them will surprise you if you've been watching us for a while. If you haven't been watching us for a while, Simon and myself both put out a video every day solving variant Sudoku, or sometimes a puzzle very like it. And we talk you through how we solve it and the conclusions we reach. And those conclusions can be of interest if you're looking to solve Sudokus, if you're looking to understand how the human mind works. AI has been looking at our videos sometimes to try and learn from us. We had a partnership with Sakana, well, we have a partnership with Sakana in Japan, and they're using our videos. It's great to see. Now, what else is going on? We've got, of course, a Patreon account where we put out a Sudoku hunt every month on the 1st of every month. So check that out. 1st of the month. It's a competition till the 20th. Then it just sits there, and if you're just paying us $2 a month, you get to see those puzzles and try them. If you pay us $3 a month, you get to see solution videos to the puzzles as well. And there's also crosswords and connection videos on Patreon, loads of stuff. There's SVEN'S SUDOKU PAD linked under the grid and in the description field, and also, of course, our apps, which feature such things as Line Sudoku, Domino, Killer, Thermo and Arrow Sudoku, as well as Fog of War and The Worms by the likes of the brilliant constructors Phistomefel and Michael Lefkowitz. Now, I don't know Molly Boody, but Molly has sent this puzzle, and the rules I am going to go through now. Look at the question marks in the grid. They all have a little dot underneath them, a black dot. This one is obviously upside down, so its dot is a arrow circle. This one has a thermo bulb, and this one has a quadruple circle as a dot. It's very neat, very neat. Now, the rules are as follows. Normal Sudoku rules apply. That means 1 to 9 will go in every row, every column, and every 3x3 box. Digits in cells separated by a black dot, one is double the other. The sum of the digits in a cage is shown, so those 2 cells add up to 7. Where are we? Thermometers. Digits on a thermometer increase from the bulb end. Along a green line, any 2 neighbours have a difference of at least 5. That's the German whisper rule. These 3 cells on the arrow add up to the number in the circle. And around this circle, which has 4, 7, 7 in it, there must be at least 1 4 and at least 2 7s. So those are the rules. It's very straightforward. As there's very little marking in the grid, very little clutter. That's what I was going to say. That's what I mean by straightforward. I mean, there's quite a lot of rules involved, but nothing unusual for us. Do give it a try on that first link under the video. Even if you're new, it might be approachable. You can judge perhaps from the video length how hard I am about to find it, and I'm about to do that. Let's get cracking. So I'm going to start in the 7 cage, because as I was doing the rules there, it occurred to me that achieving a difference of 5 on these 2 cells, which are joined by a green line, can only be done if they're going to be 6 and 1. One of them has to be 5 more than the other. So that's what we're getting here. Now, if this digit was the 6, that would have to be a 1, but so would that. And that would be 2 of them in the same box. Not allowed. So this is the 1. That's the 6. This must be another 1 as we go along the green line. And this one is going to be high. Some of the rules we know we get to learn about green lines are that you can't put 5 on them. There are no possible neighbours. That they alternate, therefore, between numbers higher than 5 and lower than 5 to maintain this difference. And it's quite difficult to put 6s and 4s on them, because if you can't put them in spots where they've got 2 neighbours that see each other, which is exactly what we just experienced here. So this cell is 7, 8 or 9. This one is 1, 2 or 3 on the black dot. That's not all that helpful. Then the next digit on the black dot is 2 or 1 or 4. It can't be 6 because that's already appeared in the column. So that one can't be 3 anymore. Now this is a little better. We know that one of these two must have a 2. And this is a higher digit, 7, 8 or 9. So a good start on this arrow because it had this extra cage on. A good start, not on this arrow, sorry, on this question mark, this German whisper line. Now, this one, this is good. We can work out the polarity of this digit, by which I mean whether it's high or low. Because at the possible lowest start of this thermo, now we've got rid of 1 there. The lowest start is a 2. That could be 3. This could be 4. But that would involve this being the only possible low number, 4, while this was a 3, and they're green line connected, so that doesn't work. So this must be a high digit. And then, as I said, we can alternate. This is low, 2, 3 or 4. Since it can't be 1, that's not 6. This is 1, 2, 3, not 4, because its 2 neighbours are in the same row. This one can't be 6, because this digit can't be a 1. This one is low. I'm going to put 2 or 3. It can't be 4 because its 2 neighbours see each other, and it can't be 1 because of that. And now we've got a 7, 8, 9 triple in the box. We've also worked out where 1 goes in row 3. It's got to be here. Now this 7, 8, 9 triple is interesting because one of them has to be a 7. And 7 can only connect to the numbers 1 and 2. Oh, this digit has stopped being able to be 1. This can't... No, that's nonsense. I was going to say it can't be a 3. That's not true. This is lower than 2, 3 or 4, but it's not 1. So that's 2 or 3. This is 3 or 4. And now this can't be 7. Because of the difference between those 2 cells. Now, one of these 2 in the box is 7, because remember that's a 7, 8, 9 triple, and if this one can't be 7, one of these 2 is 7. That means this digit can't be 3, because 3 touching 7 is only a difference of 4. So that becomes a 2. But I still don't know which of these 2 is 7. I do know the other digits in the box are 3, 4, 5, 6, and we can't have a second 6 in the top row. But we've got quite a lot out of that one. I'm tempted to move on to this question mark next. These 2 cells are on the arrow, and that works a bit like this cage. Not quite the same. You might be tempted to think that the only way you can make up a single digit in 3, including a high digit, is 1, 2, 6. It's not quite true, because I think these could be 1, 7, 1. Clearly they won't have 2 high digits alternating there and there, so this is the high one. I'm going to put 6, 7, 8, no, I'm going to put 6 or 7 there, because we've ruled this down to either 1, 6, 1, 1, 7, 1 or 1, 6, 2. So those digits are definitely selected from 1 or 2. This circle is definitely 8 or 9, which is a bit of a pair with that one. This is a high digit that now can't be 8 or 9 because of that pair I'm just highlighting to you. So this digit has to be 6 or 7. That is a pair in which 1 must be 6, and on the green line this digit now must be a 1, because it must be touching at A6 on the green line. Now, this digit is 1 or 2 because of that being 6 or 7, but it can't be 1. So that's a 2, and now this can't be 6. That's a 7. This is another green line 6. Just when I told you they were quite rare beasts at the start, we found one. Oh, I've just marked that as a 1, and now, yes, because this is a 6. Couldn't remember why. And now they don't add up to 9, they add up to 8. That's an 8. This is a 9. These two are not 9s in the box. That 2 is looking at this cell, so that's a 3, and that can't connect to 7. So we've sorted out the 7, 8, 9 pair in box 3. It's a very neatly done puzzle, this. Now, 9 and 8 there are looking at a 7 here, clearly. That one now can't be 7. This hasn't changed with that being a 7. Let's look at No, 6 is looking at that cell. So there's only one place for 6 in box 3. What digit is missing from here? 2. 2 is not appearing anywhere in the column, so it must go in there. And this one is 3, 4, or 5, part of a triple with that. And in fact, that will be the same digit as this. Now, Sudoku, no, German whisper rules say that this is a high digit. And it's not 6, 7, or 8, so it must be 9. That seems to be fine. Now there's a 9 in one of those two cells. And didn't I say, I was going to say that this digit has to be in one of these 3, but it could be the 3, so it doesn't necessarily form a pair with the 9. Now, it may be time to move on to this 4th question mark as we go round clockwise. And the really interesting thing about that is that there are 2 7s around this quadruple marker. So there must be a 7 in box 5 in one of those cells and a 7 in box 8 in one of those. If that was a 7, this digit would be a 1 or a 2, but it couldn't be a 2 because there'd be a 2 there on this black dot. This would have to be a 1. Okay, I'm not really sure how this one's going to work yet, so I might have to do some Sudoku to figure it out. There's a 7 in one of these 2 cells, but we actually know which one, because the 2 7s here are going to use up the 7s for column 4 and 5. That's what we call an X-wing, and that means that this digit in column 5 can't be another 7. We're going to have used the 2 of them down there, so this is where 7 goes. It doesn't really get anything else done, does it? There is a 7 also in row 8 in one of those 2 cells. In column 9 in one of those 2. Oh, sorry, that wasn't meant to be a full digit. That was meant to be, also here, it was meant to be a corner mark saying that's where it's confined to in the box. 7 is in one of these cells. I feel like I should know more about this whisper line at the moment than I think I do. There is a 4 somewhere here, but I can't even rule it out of there. So let's do some thinking at this point. We need a 1 in this box in one of those cells, an 8 in one of these. 9, and then the other digit here is 4 or 5. The other digit in this pair is 3, 4 or 5. No, this isn't getting anything done. I need to look at something on this green line. What's going to tell me whether it's high or low? This one can't be 1 or 9. If it was a 7, it would have to be surrounded in the box by 1 and 2. Aha! This digit can't be 1 or 2, so that can't be 7. So this is 7. So that didn't tell me what was high and low on the line, but it did tell me where that 7 is not on the line. Now, 6 can't appear anywhere on this line. I know that because I've got that 6 ruling it out of those cells. 6 in either of those places would have to be sitting next to a 1, and these positions for 1 prevent that. And 6 here would have to have 1s in both those cells. So there is no 6 on this line, and the only possible place for 7 on it is here, because that 7 sees all the other cells. So apart from that cell, any high digits on this line are 8 and 9. And one of them must appear here and be the other digit from 8 and 9 from that one. One of these must be an 8 or a 9. Oh, it's quite interesting. For this to be high, it would have to be 8 because it sees a 9. And then for this to be low, it would have to be 3 because it sees a 2 and a 1. So for this one to be high, we'd be going 3, 8, 1 or 2, 9, then a low digit. I mean, it looks like it does work. I was hoping to rule it out. So for this to be high, then I feel like you wouldn't get any 1s on the line, because if these were the low positions, they all see a 1 in various guises. That's a bit strange. Neither of these two could be 4s, so they'd have to be 2 or 3. I am going to just mark up what these cells can be now. We've worked out this can't be 6 or 7. So if it's high, it's 8 or 9. If it's low, it's 2 or 3. This one is not 6 or 7 again. If it's high, it's 8 or 9. If it's low, in this case, it's not a 2, because there is a 2 on that black dot. But maybe I can't even rule out a 4 from that cell. That's strange. Now that's indicating that I shouldn't be doing this method. This can't be 6 or 7, so if it's high, it's 8 or 9. If it's low, could be any digit. So this is not being very successful. Okay, forget that. Let's get rid of all that. That's too many pencil marks to be helpful. Should be able to do, 6 in this row. That's just physically done. That's easy. Right, 5 in the row has to be in one of those cells because it can't be here. Yeah, a bit of Sudoku. Maybe that'll calm the nerves. 6, and that's 6. Say that none of these can be 6. That cell also can't be 6 because of its position on the green line, and that one can't be 6. We worked that out earlier because this digit can't be a 1. So 6 is actually placed in box 7. And then I get 6 in row 8. I'm going to run out of steam on 6s because all of these places in the columns can be 6s. But still, at least we got a 6 down here. Now, we worked out if this is low, we're going 3, 8, 1 or 2. Could that be 8? I just don't know. This one is not really constrained by anything we've done in the puzzle. Okay, this come to a bit of a crunchier point than we had earlier on when we were cruising around the question marks and getting lots of information about them. Right, I need to do some little bit of thinking now. We've got 7 and 6 confined here. This digit, I do feel that's interesting. I'm going back to the pencil marks for that. 2, 3, or 8 or 9. Now, if that's low, these two, look. It's blindingly obvious. Those 3 digits, let's make them all yellow, because these are the alternating positions. They're all the same polarity, and they're all in the same box with a 7 and 6. They can't all be 8 and 9, so they're definitely low, which I would normally colour as blue. So they're from 1, 2, 3, 4. Now, this one can't be 1 or 2. This is where we do get going here. It's been very clear, sorry. I should have done that colouring along the line, and I just didn't. Right, this digit can't be 4 because that can't be 9, so it's a 3. Remember, it sees 1 and 2. This digit has to be 5 away from 3 and isn't 9, so that's 8. These two now can't be 3s, and nor can that one. In fact, this has to be a high digit because we're alternating along the line now. Now, 8, 7, 6, 3. This can't be 4 because that won't work on the German whisper juxtaposition. And 8 there is looking at this cell, which becomes a 9. It's probably not going to do a lot else. 8, 7, 6, 3. We have still 1, 2, 4, 5, 9 to place in the box. I bet that's not 9. I'm rather thinking that that's likely to be an 8. Oh no, look, here's a 1, 2, 4 triple. One, 2, 4, 7, 6. So the 3 and 8 in the column must be in those cells. And these are a 5, 9 pair. Now this digit is from 1, 2, 4 and can't be a 1. So we've got this 1, 2, 4 triple here. This is high, obviously. I should be using this quadruple better. I don't know quite how to use it yet. Maybe I look at this row, 8, 7, 6, 1, 9. That one can't be 2 or 3, so that's 4 or 5. No. Oh, we need a 2 in the row. Oh, 9 is looking at that cell. It's just done, isn't it? Oh, every digit in the row is done. I just hadn't realised. Right, 3, 4, 9, 2, 7, 6. We need an 8 in the box. There it is. And a 1, 5 pair. That is now a 3 because we can't have 3 in those cells. We get a 3 in the corner. That's 3 in the corner. That's 3 in the spotlight, proving its position. That's a 9, 5 pair here with a 4, 6, 7 triple. Now, 1, 2, 4 are looking at that cell, so it can't be a 1. This is a 4, 5, 8 triple. This one's still not resolved, but we have 3, 7, and 9 to place. Now, there's a 4 around this, as well as an extra 7, so they have to be a pair here. This is now a 4, 7 pair, and one of those two is a 7, so that's not. Now, the 4, 7 pair are looking at this cell over here, so that's a 6. And this row feels like it's going to yield something. 4, 7, 6, 1. Everything else is from 2, 3, 8, 5, 9. I don't have many limitations on 2s and 3s though, so not quite as helpful as I was thinking it was about to be. 2 is looking at that cell. I don't know how long that's been happening for. Probably a long time. 1 there, 2 on the black dot. This is 4. And that's really useful on the green line. Those become 9s, that's a 2, and all the green line cells, oh no, apart from that one, are complete. I can finish off 3 and 7 there, that gives me 7 and 4, and this quadruple clue is fulfilled, fully fulfilled I was going to say, but it feels a lot quite tautological. Now, still haven't worked out that 3, 8 pair. Let's look at this column. 6 here, 4, 5, 8. Are the other digits to place, not that useful. 3 is looking at this digit, so that's the last green cell. That becomes a 4. This can't be 4, we've got 4 in the bottom row. These digits in the column are 3, 5, 8. Only one of them can be 3, that's there. That's going to give us a 3 in one of these cells. Don't know the answer. There's a 1 in the central box. That has to be there. I think that's the last one in the puzzle. 2 now has to be here in box 5. Everything else in the box is 5, 6, 8 or 9. Now that 9 is looking at this cell. That's a 5. Then we've got, this must be a 3 because it can't be 8. That 8 gives us 3 in column 3. 6, 3, 7, 1, 9. 8 has to be here because of these 8s looking into the box. 4 then has to be up here in the corner. Then we can do 2 and 5. This is a 6, 4 pair, I do believe. This is a 5, 7 pair. Is this digit not resolved? It will be in a second because that 4 is looking at this cell. Now that 5 is looking back at this one. Then we get a 5 here. That sorts out 7, 5. That sorts out 7, 4. That sorts out 4, 6. Now we can finish off these rows. We've got a 6 here. 8 and 9 here. Not actually resolved. But this one's a 3. This one's a 5. Up here, a 2, 9 pair. They are resolved by the 2 that we have in box 5. That gives us 8 and 9 here, and that gives us 8 and 5 at the bottom. And it's a lovely puzzle. I sort of jogged through, and I think I took them in the right order. We went round the grid from this one to this one, finding our way through the question marks and answering the questions they posed. I did get a bit stuck over here. Highlighting those 3 as being of the same polarity was very much the key for me. But a lovely puzzle. Thank you, Molly, for sending it. Good fun. And that's what we like on the channel. And that's why we will be back again, doing it all over with a different puzzle. And we'd love you to join us. Thank you so much for watching, and bye for now.